presentation, we'll review what force is, we'll explain the difference between contact and non-contact forces, and we'll explore the concept of magnetism. So what exactly is a force? Well, very simply, a force is just either a push or a pull. And hopefully you learned about this in kindergarten when you did your pushes and pulls unit and you built a windmill. But even if you didn't, you should know that anytime you force an object, you give it a push or a pull. And that's what causes motion. To make an object move, you need a force. So what are some different kinds of forces? Well, some forces require contact. And that's just a fancy term for touch. Some forces are a result of objects touching. One of those examples would be friction. Friction occurs anytime two surfaces or two objects rub together. A classic example of that is when you rub your hands together. If I rub my hands together, there's a lot of friction. It's harder to move my hands than if I was just moving my hands without actually touching. There's a lot less friction when I'm not touching my hands together. More friction, less friction. You could try that. You can actually feel the difference. So that's one example of a contact force. Another example of a contact force is if I were to actually push or pull something by making contact, by pushing it. Some forces don't actually require objects to be in contact or to touch each other. And so we call them non-contact forces. Now, some of you may know Star Wars. I love Star Wars, by the way. But unlike our buddy Finn here, who says he's going to use the force, we're not going to use that kind of force. Sorry, that's not a real thing. But we are going to use some real forces that don't touch but can still affect an object. And those forces are magnetism, which we're going to explore in this presentation, electricity, and gravity. So check out this video clip. What do you think is holding those objects up? What's keeping them from touching each other? I'll give you a hint. The objects are all made of metal. There are no strings, but there is something that's keeping them from touching each other. What do you think it could be? If you thought that those objects were magnets or that magnetism had something to do with the objects not touching each other, you're right. Good job. So what is magnetism? What are magnets? Well, let's start with what magnets are. Magnets are metal objects, and they either attract or repel certain objects, and they have a force that we call magnetism. And a magnet, here you can see what we call a bar magnet, has two ends. There's a north and a south pole. Now that might sound familiar to you. You may have heard that the Earth has a north and a south pole. And that's true because the Earth is like a big magnet. It has a magnetic north and a magnetic south pole. But for now, let's just focus on bar magnets. And so this is a metal object. It has the force of magnetism, and it can attract or repel things. And we'll explore what we mean by that in just a second. So just to be clear, not all metal objects are magnets. Only certain metals with special properties are magnets. They have the force of magnetism. So all the objects that we're going to look at here are magnets. And what we're going to do is we're going to explore how magnets interact with other magnets depending on the way that they're laid out or the way that they're oriented. Okay, so let's look at this first scenario. Here I've got a magnet and it has a north pole, and I'm going to bring another magnet with its north pole end towards it. Now, what do you predict is going to happen when I bring a north pole close to a north pole? Let's see what happens. Aha! They push apart. Well, why is that? Well, because for magnets, like poles repel. Repel means to push apart. Similar poles like a North Pole and a North Pole, they don't want to be near each other. So what happens when we bring them close, they force each other apart. They push apart, and we call that repel. So we say like poles repel. Now let's look at this next scenario. Here I have the South Pole end of a magnet, and I have the North Pole end of a magnet. Now, what do you predict will happen when I bring those two magnets together? Well, let's see. Aha, something different. This time, the South Pole and the North Pole pulled together. We call that attract. So we say opposite poles attract. A South Pole and a North Pole, they want to be together. So when I bring them close, they're going to pull together, and we call that attract. So we say opposite poles attract. Now let's see if you can figure out this last scenario. Here I have the South Pole end of a magnet, and I'm going to bring the South Pole end of another magnet in close. Now what do you predict is going to happen when I bring South Pole and South Pole together? Well, let's see what happens. Aha! Did you predict that they were going to repel, that they were going to push each other apart? If you did, good job. So, in summary, what do we need to remember? Well, we need to remember that opposite poles attract. They pull together. So, a North Pole and a South Pole, when I bring them close to each other, they're going to attract. They're going to pull together. Like poles repel. So, a North Pole and a North Pole, or a South Pole and a South Pole, when I bring them together, they're going to push each other apart. They're going to force each other apart. They're going to repel. Opposites attract, likes repel. So a key thing to remember about magnetism is that a magnet doesn't have to actually touch another object to have an effect on it. For example, if I had those magnets coming together, you notice I said when they got close, they'll either attract or pull apart. That's because before the magnets even touch, they start to affect one another. And if it's opposite poles, they'll pull each other together. If they're like poles, they're going to push each other apart, but they don't have to touch each other before the force of magnetism acts on the other magnet. So what effect does the distance between objects have on the strength of magnetism? So let's make a prediction here. Let's think this out. Here I have a North Pole and another North Pole end of a magnet, and they're pretty far apart. Now, I'm exaggerating this, but let's just pretend that these are really strong magnets, and they're going to have an effect on each other. Now, what do you remember? North Pole and North Pole, like poles, what's going to happen? Are they going to attract or repel? Hopefully you said they're going to repel. So last time when we had magnets repel, they got close and then they really pushed apart, and we saw a really big effect on that magnet. Now these magnets are pretty far apart. So what do you think? Do you think that magnet is going to repel really far, or is it going to repel just a little bit? Remember, it's a pretty far distance between them. So what do you think? Will it repel a little bit, or will it repel really far? Well, let's see. It only repelled it a little bit. And that's because the farther a magnet is from another object, the weaker the effect that its magnetism force has. That makes sense, right? Because if it's really far away, I need a much bigger force to impact that object. And so if I've got a magnet and I'm close, I'll be able to attract or repel pretty easily. But if I'm far away, it's going to be a lot harder to affect that object because the force isn't going to be as strong over a large distance. So let's see if you can figure out this next scenario. Here I've got the South Pole end of a magnet and the North Pole end of a magnet. Now remember, they're pretty far apart, but what happens when I bring opposite poles together? If you said they attract, you're right, good job. But we've got a big distance, so are we going to see these magnets attract, pull each other together a little bit or a lot? What are they going to do? Remember, there's a big distance here. Let's see what happens. Aha! And there it is. You can see it up on the screen. The greater the distance, the weaker the effect. So we only saw that magnet attract or pull to the other magnet just a little bit. So keep in mind a couple of key things. Okay? In magnets, opposites attract, opposite poles attract, like poles repel. The greater the distance between a magnet and the object it's affecting, the weaker the effect of magnetism.